In this lecture, we're going to continue with data wrangling, but we're going to think about aggregation. How do we generate summary statistics like means and standard deviations by group for a particular data set? And we're going to use the pandas group by function, which is really useful in these circumstances. As always, the code is in your GitHub repository, and follow along actively while you're watching this lecture. Pause it when you need to and experiment yourself. So let's start off by loading the data that we used in the previous lecture. So this is exactly the same code as we saw before. We're importing pandas, we're reading our three data frames, and we're setting the index, and we're joining them, and let's look at the first 5 rows. So this is what we had before. So this is just a recap from what we did in the previous lecture. Now, many of the questions that we want to ask are going to involve some form of aggregation. And group by does this for you. You need to think about what you want to aggregate over, and that's a field that you group by. So for example, if we want to know for drivers who are intoxicated versus drivers who weren't, what's the average number of people who are killed or injured in a particular collision? So in this case, we have a field called party sobriety, so let's group by it. So this is our joint data frame. We're going to group by party sobriety. What do we want to report? Well, we want to report these two columns, the number of killed and number injured. And then let's look at the averages. So we get party sobriety. If we want to see what A is, let's look at the codebook. So for party sobriety, we see that A had not been drinking, and then B, C, D are various levels of drinking and impairment. So we can see that people who have not been drinking, here we get actually fewer people killed than in this category B, but actually no one in C and D. Just a quick warning here, these are not accurate averages per collision, and I want you to pause the video and think about why in the context of how we joined the data frame. Well, remember in this join data frame, we have more than one row per collision. We had a one-to-many join. So these are actually averages that are weighted by the number of parties. So you can think of these, so if you have a collision with two parties, that's actually represented twice in our data frame. So these average numbers of killed and injured are not going to be the averages per collision, but they're going to be the weighted average. So that's just a detail to be aware of if you're trying to interpret these results. Sometimes we need to transform the data before we do a group by. So let's look at collisions that involve pedestrians. We're going to do the same, group by party sobriety. We're going to take the mean of whether this collision involved a pedestrian. And we get an error. As always, read up from the bottom when you get an error message like this. And where is it? It's a long way down. So we get a more cryptic error message here. We get an unsupported operand type for plus, int, and string. So what went wrong? I'd like you to do some troubleshooting. Pause the video, see if you can figure out what's the issue, and a hint, look at the data field that we're aggregating over first. Well, let's do that ourselves. So let's look at our pedestrian access field. So let's look at the first 5 rows with head, and then let's look at the unique values. And immediately we see what might be the problem. This isn't a number that we can average over. These are y's or NANs in the first 5 rows. And if we look at the unique values, it looks like all the rows are either y or null. So we're trying to calculate the mean of a column that only has y or nulls, and pandas doesn't know how to do that. So it's not surprising we get an error message that, hey, we have this unsupported type. Basically, it's a little cryptic, but basically we can't do this operation on a string. So we can fix this error by creating a new column. we're going to create a Boolean column. So Boolean is true or false. And that's going to be true if our pedestrian accident value is y and false otherwise. And then we can take the mean. We can take means of true or false because true is considered 1 and false is considered 0 when we're doing operations like this. So here we're creating an array of true or false. So if pedestrian access is y, this is going to return true. If otherwise, it's going to return false. And then we're going to store the result in this new column, ped accident Boolean. So we can see that if there's a y, we get true. If it's a null or any other value for that matter, we would get a false. We can do this in a slightly different way, in a function. And this function is a little easier to adapt if we have multiple circumstances. We don't just have 1 or 0. So what are we going to do here? Well, we're going to take this ped accident value and add it to our function that we're going to call convert to bool. And if this is y, we're going to return true. Otherwise, we're going to return false. So now we've defined this function. How are we going to use it? We're going to use the pandas apply function. So we're going to take whatever's in this column one at a time and pass it through apply to this function. So convert to bool is what we just defined here. And then we're going to store the results in this column. So we'll overwrite that column that we had before. We get exactly the same results as we did before. A third way to do this, which is the most elegant and concise, even though it might be a little harder to get your head around at first, is to use what's called a lambda, or an anonymous function. And here what we're doing is we're taking a joined data frame pedestrian accident column, and we're using apply again, but rather than applying a function that we already predefined, we're going to define this function on the fly as a lambda function. So what this does, lambda is an indication that this is an anonymous function, or a lambda function, and that the value of pedestrian accident is going to reappear in the variable x. Then what are we going to return from this? Well, we're going to return true if x is y. Otherwise, we're going to return false. And we get exactly the same results. So now we have this Boolean column. Now we can go back to our group by. So we can group by party sobriety again, and we can look at the mean, what involves a pedestrian accident. And we see that 7% of category A involved a pedestrian accident. They involved a pedestrian, but just 4% of category B. So we looked at means here. We can also generate standard deviations, counts, sums, and more. And the documentation for group by gives a lot of examples and of what we can do. So we split the object into groups, and then we can, further down at the bottom, there is going to be some examples of aggregation. So we can have sums here, for example. We can describe, and we can get lots of different categories in terms of their percentiles. So this is very flexible. We grouped by an index before. We grouped by we grouped by a column, party sobriety. We could also group by an index. And we tell pandas we want to group by an index using level equals 0. So if you want to group by your index, for example, if you want to group by census tracts, and census tracts is your index column, then you don't have to promote that index to a column. You can just group by on the index. So let's make this concrete. So size gives a number of rows in each group. We could also do this if we create a temporary data frame that has party sobriety as the index, and then rather than grouping by the column, we group by the index, level equals 0. It's 0 because 0 is a first column at the index in a case where we have multiple index columns. And then we're also going to do the size of each group. Or we could do these two in a single line, join data frame set index, which returns a new data frame with party subhierarchy in index, and then we group by and then the same size as we did before. So all these three, I hope, are going to produce the same result. So we have 560 rows in category A, 26 in B. Yes, so it looks like these three methods gave us exactly the same results. Another group by operation you might want to do is sum. So these are the totals in each column. So this is telling us the number of true values, because remember, it's 1 if it's true, 0 if it's false. So a sum here is the same as a number of true values. So here we have 39 accidents involving a pedestrian in category A, and 1 involving a pedestrian in category B. So group by is very powerful. Once you get the hang of the basic syntax, it's very easy to calculate means, totals, sums, percentiles, any other quantity that you want to aggregate over particular groups or for your data set as a whole. So this is where we're going to leave this module in terms of data wrangling for tabular data sets. In the next module, we're going to continue with data wrangling. We're going to look at it in a spatial setting. So we're going to continue with some of the same concepts, but rather than using columns, we're going to use spatial relationships.